You've made it to the frightfully good third issue of Lightspeed. Recently, there was an event of huge proportions held at the Convention Center in Los Angeles, California. We all knew it as SIGGRAPH 95. The convention hall was busy with people from around the world. Inside, vendors were showing off their latest technologies. There were movement capture systems for high-end 3D animation programs and incredible particle animation systems. DPS had their perception system showing in many different booths. To help turn the perception into a full-blown nonlinear system, InSync was showing their new Speed Razor editing software. Many people scurried around, most stopping to look at some of the neat virtual reality systems on display. There was even a booth showing off their virtual hang gliding system. You and a friend could have a crack at each other playing some hot new video games. Other manufacturers showed their version of image processing and motion control software. You could try your luck at a new job while there or visit familiar faces. All in all, it was a fantastic show. And when it was over, we couldn't wait until next year. Now let's get to the goodies.
Hi, I'm Dave Warner, back for another issue of Lightspeed. This month I'll be showing you some more tips on how to control your camera and objects a little bit better. This lesson will build upon things that I showed you in the very first issue of Lightspeed, but it's not mandatory that you have that issue, although I do recommend you pick it up. Now before we get started, let me tell you that I'm running Lightwave 3.5 on my Amiga, so some of the screens that you see may be a little different from what you have, but don't worry about it. Everything I'm going to show you will work the same on pretty much all versions of Lightwave. So let's get started. If you haven't done so already, then start Lightwave now. And for those of you who do not have the Lightspeed companion disc, we're going to model an object here. The first example I'm going to show you, we will need a lighthouse object. So go to Modeler, select Polygon, Points, and we're going to zoom out of Modeler using the comma key until the grid size is equal to 5 meters. Now press the N key for numeric. And our first point is going to fall at 5 on the x-axis, and y and z will be left at 0. Press return to make that point. Click numeric again. The second point will fall at 4.5 on the x-axis, and y and z will be left at 0 again. Press return to make that point. Let's move up a little bit in the face view so we can see everything. Press numeric again. The second point will fall at 2 on the x-axis and 20 on the y-axis. Make a point there. And let's zoom out just a little bit more so we can see all 4 of our points here. There they are. Click numeric again, and the second point will fall at 2.5 on the x-axis and 20 on y. Press return to make that point. Hit the space bar, and now click make to make this into a polygon. Now we're going to select multiply, and we're going to lathe this. Click on numeric. And in the requester here, we're going to lathe this 360 degrees along its y-axis, but we need to increase the number of sides to 32 to make it very smooth. And also click on Y, because that's where we're going to lathe this object around. Click on OK, and press return or make. And we've lathed the exterior and interior walls of our lighthouse. Hit the space bar. And let's set our polygon surfaces while we're here. Let's call this lighthouse walls. Press enter. Now let's go to layer 2, and we're going to now model a step that we're going to turn into a winding staircase. So bring up the lighthouse object in the background, go to the Objects panel, select Box, press N or click Numeric, and for the low value, first we're going to shift to meters. The low X value, we're going to type in 2.5, Y and Z will be at 0. The high X value will be 4.55 and 0.2 on the Y, and on Z we'll just put in 1. So we're making a box that's a little bit over 2 meters long, 0.2 meters in height, and 1 meter in width. Click on OK, press Return or Make, and we've made our box. Now go to the Multiply panel, select Clone, and since our step is only 0.2 meters in height and our lighthouse is 20 meters in height, we are going to need to clone that step 100 times to reach the top of the lighthouse. And we'll offset each step by 0.2 meters. We want the staircase to wind around the interior of the lighthouse counterclockwise 2 times. So that's minus 720 degrees divided by 100. We'll offset, or we'll rotate each step by negative 7.2 degrees. And we want the staircase to taper off as it reaches the top. So we're going to scale along the x-axis by 0.991, leave y alone, and do the same for z. Scale it by 0.991. Leave everything else the same. Press Return or click on OK, and there's our staircase. Now if you highlight both layers, you see that we've got the exterior of the lighthouse set and the staircase. Let's go back to layer number 2 and need to name our stairs. Call them lighthouse stairs. Apply that. Select both layers again, and you'll need to finish off this object. I'll show you a picture of what your lighthouse should look like when it's done. And here it is. Now you'll need to make a hole in the bottom of the lighthouse with Boolean subtract. Also put some doors in there. This will be your main opening in the lighthouse. For this I also put a walkway at the top here with some railings around it, a roof, windows and everything. Inside of there is the lamp casing. I've actually got a light placed inside of there, and I also made a cone object using grid with a fall off texture for luminosity and transparency to make this kind of bright glow effect here, which will show up very nicely with a black background. So this is what your lighthouse should look like, or pretty close to it, for this tutorial. Now let's go back to layout. Now if you've been following along with the modeling exercise we just did, you'll need to save your object and then import it here into layout. Also set your surfaces, add your lights and everything. For those of you with the Lightspeed companion disc, go to the scene menu, and we're going to load in the scene off of your Lightspeed companion disc that's called Lighthouse 1 Point Light Wave Scene. This is the lighthouse with all of the lights and some keyframes set for the doors to open and everything. We've also got the light rotating so that it completes the lighthouse effect. We'll take a look at this from the perspective view. As you can see, there's our lighthouse, the cone, which is our light glow effect. The doors and everything are there that you just saw in the image that I rendered. So now let's go to the Objects panel, and we're going to set up our camera's motion paths, and we're going to use null objects to control all of the movements of the camera. So now add 4 null objects. We're not going to bother renaming them in this section now. It might help if you do rename them though to something that makes sense to you, like camera null object or something like that. Now let's take a look at this from the side. Select Object. We're going to start setting up our object hierarchy here. We're going to parent null object number 4 to null object number 3. Select null object number 3, and we're going to parent that to null object number 2. Select null object number 2, and we're going to parent that to null object number 1. So now all of these null objects here are parented to each other, and they're set up for us to parent our camera and that's going to be parented to no object number 4. So the camera is going to be at the very end of this hierarchy. Let's set our position for the camera right now. Move that to -3 along the z-axis. Make a keyframe for that at 0. Let's go back to objects. Select no object number 1. And we need to move this a little bit on the y-axis so that the camera is not level with the ground, so it comes at a nice height through the doorway. We'll type in 1.5 along the y-axis, make a keyframe for that. Now select no object number 2, numeric input. We're going to move this to 100 meters along the y-axis, make a keyframe there, and we're going to set our spline tension to 1. And now select no object number 3. We're going to move this -100 meters along its z-axis. Make a keyframe for that, and we're going to set the spline tension to this, for this to 1. Now select no object number 4. Now let's take a look at this from the camera view. We should be able to see the lighthouse from this view, but we don't. So we need to select rotate. And we're just going to type in the value here. We're going to give it a 40-degree rotation on its pitch axis. As you can see, that lines up pretty well. Make a keyframe for that. Set our spline tension again to 1. Now let's go to frame 200. Select our no object number 1 again. And we're not going to make any changes to this, but we are going to make a keyframe, and we're going to set our spline control. We're just going to turn linear on. Select no object number 2, and we're going to move this to only 25 meters on the y-axis, and we're going to rotate it on its pitch axis by -90 degrees. Make a keyframe for that at 200. Select spline controls and turn on tension to 1. Select no object number 3. We're going to move this to -25 meters on its z-axis, and we're going to rotate this by 90 degrees on its pitch axis. Make a keyframe for that. Again, set the spline tension to 1. Select no object number 4. And for this one, we're just going to reset the pitch of the rotational pitch to 0. We'll make a keyframe for this, and we're also going to set the tension to 1. Now we also need to make a keyframe here for the camera, and we're not going to make any changes to it, but we are going to set our spline tension to 1, and we're also going to turn on linear so it stays in place. Now let's go to frame 250. Since we've got the camera selected, let's make our changes to that. Take a look at it from the overhead view and zoom in enough so you can see the camera clearly. We're going to rotate the camera by 90 degrees on its heading. Make a keyframe at 250, and we're going to set our spline tension to 1. Now select object and no object number 1. We're going to make a keyframe for this, but we're not going to make any changes to it at 250. And we're not going to turn any of the spline controls on. Select no object number 2. This one we're going to rotate -90 degrees along its bank. Make a keyframe at 250 for this. We're not going to change the spline controls at all. Select no object number 4. And for this, we're just going to make a keyframe at 250. We're going to set the spline controls. We're going to turn on linear. Now we're going to go to frame 250, or actually frame 1050. Select no object number 1. Now this we're going to rotate along its heading by -720 degrees so that the camera follows the spiral stair path up. And we're also going to change the size of this on the X and Z axis to 0.45 on X, leave Y at 1, and 0.45 on Z. So that will shrink the camera's path as it spirals up the stairs. Now let's make a keyframe for this, and we're going to set our spline control with linear on. Now we're going to select no object number 4. We're at frame 1050. This we're going to move up by, on the y-axis, by 20 meters. Make a keyframe for that, and we're going to set our spline controls with linear turned on. If you take a look at this from the side, let's select the camera, and we're also going to make a keyframe for the camera at frame 1050, center the camera, and you'll see that this camera is following the spiral path all the way up the stairs, and it tapers off as it goes up. If we take a look at this from the overhead view, you'll see that the camera kind of spirals in as it makes its way up the stairs, like so. So we've made a keyframe for that at 1050. Let's set our spline tension to 1 and turn linear on. Now we're going to go to frame 1100, and we're going to rotate the camera by another 90 degrees so that it's facing the 180 degrees on its heading. Make a keyframe for that, and we're going to set our spline tension to 1. And that's the final keyframe in this example. The camera, when we animate this, the camera will fly into the lighthouse, follow the spiral stair path up the stairs. When it gets to the very top, it'll turn and look out the side of the lighthouse. So now let's save this scene. You'll find this on your Lightspeed companion disc if you have it. It'll be called Lighthouse 2 Lightwave Scene. We'll save this. For those of you who do not have the Lightspeed companion disc, you'll want to set your surfaces, your lighting, and your camera attributes now. And what I'm going to do is render this animation out and show you the results. And here it is. Obviously the camera flies into the lighthouse and starts its way up the stairs. Certainly nothing earth-shattering, but this could just as easily have been some sort of animated character running up the stairs and following the same path that the camera took. Now, the settings that I've given you in this example are by no means absolute. You could probably have gotten the same results by just using 2 no objects instead of the 4. But for the purposes of this particular tutorial, I wanted to show you how the use of multiple no objects can really make a big difference in the movements of your camera and other objects. Now, in the second half of this tutorial, we're going to be loading in the corridor lightwave scene off of the Lightspeed companion disc. For those of you that don't have the Lightspeed companion disc, you'll want to make 3 different 1 meter boxes. What I've done is just made regular boxes in Modeler and imported them into the layout, and what I did was I named their surfaces 3 different things. I've got one that's called walls, another one that's called ceiling, and another one that's called floor. And what I've done is arrange these in such a way that they've kind of made a little corridor, and what we're going to do is fly the camera through this corridor here, sort of like a little maze. Now we'll start off by adding 4 different no objects. And what we're going to do is rename these to something that's going to be a little easier to understand. The first one is going to be called Turn 1. The second one will be called Turn 2. We'll rename the third one to Turn 3. And the fourth one will be renamed to Turn 4. Now let's go to layout, and what we're going to do here is set up our hierarchy a little bit different from the one that we did in the first example. Turn 1 is going to be parented to Turn 2. Turn 2 will be parented to Turn 3. And Turn 3 will be parented to Turn 4. Now then we're going to start positioning these no objects. Turn 4 will be moved to the very corner of the last turn that we're going to make, which is up here. I'll show you how these turns are laid out. This corner will be our very first turn, this corner will be the second one, this corner will be the third one, and this will be the fourth one. And before I go any further, I'm going to change my grid size to something a little bit bigger so it's easier to work with. And we'll have to zoom out a little bit, or zoom in a little bit. So there's the turn 4 no object. Let's position that just a little bit better so it's right on the corner. It doesn't have to be precisely there, but for this tutorial, we're going to place it as close as possible. Select the turn 3 no object, and now we're going to move this to where the corner of our third turn is at. Make a keyframe for that. Select turn number 2. This we're going to put at the second corner. Make a keyframe for that. And turn number 1 will be set right at the corner of the very first turn that we're going to make. Make a keyframe for that. Now select the camera, and we're going to parent this to turn number 1. And you'll have to position the camera so that it essentially starts at the beginning of our corridor. And now the corridors in this particular example are 2 meters wide. So we want the camera to fly right down the center of this very nicely. So let's type in a numeric value for this. We'll position it at -1 along X and -5 along Z. So it'll begin right there at the opening of the corridor. Make a keyframe for that. Now in this example, I'm going to have the camera fly at 1 meter per second. So 30 frames equals 1 second. That's going to be 1 meter every 30 seconds. Now in order for the camera to reach this point, to fly up to this null object, it's going to have to move 5 meters. That equals 150 frames. So let's go to frame 150. And now we're going to only move the camera along its z-axis from here on out. So we'll move this to 0 along its z-axis, create a keyframe there, and we're going to want to set linear. All of the keyframes that we make from this point on are going to have linear set for their spline control. Now at this point, we're going to make the camera turn around this corner, but we're not going to do anything to the camera to actually make that turn. We're going to use the null object to actually rotate the camera around that corner. Now a good way to figure out the precise amount of space you need before the next keyframe is to just multiply the rate that you're moving per second, which is 30 frames, and multiply it by 1.5. So our next keyframe will fall at 195. Before we do that, we need to set a keyframe for this null object at 150. So let's set our linear again, and now we're going to go to frame 195, because that's 45 frames away from the previous keyframe. And we're going to rotate this only on its heading by 90 degrees. Let's just type that in. Make a keyframe for that again. Set linear. Select our camera, and we're going to have to make another keyframe for the camera at this point. Even though it hasn't moved at all, we want it to remain stationary while the no object moves it. And we're going to have to set linear again. And now we're ready to go on to the next keyframe. So it's another 5 meters from this point to this point. And if you move the camera forward along its z-axis, you see that it now moves to the side, which is the way it should be because it's aligned with, it's parented to this null object, and this null object is now rotated 90 degrees, so that means that the camera is going to be moving forward even though it looks like it's going sideways. So we're going to move this 5 meters forward again, and that will fall at frame 345 because it's 150 frames beyond frame 195. Let's go to frame 345, set linear. Now select that particular null object, which is turn 2. We're going to make a keyframe for this, set linear, and we're going to rotate it -90 degrees. And it's going to take 45 frames again for that turn to go through. So that'll fall at frame 390. Let's move forward to frame 390, set linear, select our camera, make a keyframe at 390, set linear again. As you can see, our camera is now winding its way along this pathway. We'll move it 5 meters forward again. So now it's going to fall at 10. 10 meters. And it again takes 150 frames for it to move that distance, so our next keyframe is going to fall at 540. Move forward to keyframe 540. Set linear for a spline. Select no object number 3. Make a keyframe for it at 540. Set linear. And this one we're going to rotate -90 degrees also. And we're going to make a keyframe for this at frame 585. Again, 45 frames beyond keyframe 540. Let's go to 585, set linear, select our camera, make another keyframe at 585, set linear. Again, this is rather repetitive, but the end result will be worth it. And when we move forward 5 more meters, that'll fall at frame 735. It's 15 meters ahead. Again, that'll fall at frame 735. Make a keyframe. Whoops. We need to go forward to frame 735. Set linear. Select no object number 4 now, which is turn 4. We're going to make a keyframe at 735. Set our spline control to linear. Now we're going to rotate this by 90 degrees, and that will fall at frame 780 if my math is correct. Go forward to frame 780, set linear again, select the camera, make a keyframe for the camera at frame 780, set linear. And for the final move, we're just going to fly the camera forward another 4 meters or so. So it'll now fall at 19 meters on its z-axis. And this keyframe will be 120 frames from the last keyframe, so that'll be at frame 900. Let's go to keyframe 900 and set linear again. So now we're all done setting up our keyframes. If you look at the camera's path, you'll see that it flies very smoothly through this corridor. If you're wondering why it's a little closer to some of these walls, it's because we didn't precisely place our turn no objects when we were setting them up. But if you were to place them precisely on each corner of the turns that you wanted to make, it would fly right down the middle of this. So now you'll want to save this scene. And for those of you with the Lightspeed companion disc, you'll find it on there as Corrid 2 Point Light Wave Scene. We'll save this. And now I'm going to render the animation out and show you the results. And here it is. Now you'll notice that the camera motions are kind of jerky going around the corners. That's because we've had linear turned on, so they're kind of extreme movements. Now if you play around with the tension values under spline controls, you should be able to come up with a much smoother turn around each corner. But for the sake of this tutorial, I just went with linear because it's easier to work with. Now, as I said before, the settings I've given you in these examples are by no means absolute. You should take what you've learned from this tutorial and apply it in as many different ways as you can think of. And when you come up with something cool, make your own Lightspeed tutorial. Now, I promised the producers at Event Horizon Studios that I'd keep this month's tutorial below 30 minutes, and I'm pretty close. So that's all I have for this month. I'll see you next month on another exciting issue of Lightspeed.
Hi, welcome to Don't Panic, It's Only 3D. I'm your host, Kyle Thatch, and together we're going to explore Lightwave's modeler program. Over the past year in writing with Video Toaster User, I've shown you many tips and techniques to use in Modeler. The disadvantage to the printed page, though, is I really can't get into the basics you need in Modeler, such as geometric construction, pre-planning, and measurements. So let's get started with geometric construction. Simply put, geometric construction is the process of breaking an object down into its simplest shape. Take an example of a Coke can, or my favorite, a Dr. Pepper. All a Dr. Pepper can really is a cylinder. The TV that you're watching this video on right now is simply a cube. And what all this means is it's really important to break objects down into simple, manageable shapes. The object we're going to make today is a Lego block for two reasons. One, it's geometric and simple. That's pretty easy to see. And two, it's something you probably got laying in between the cushions of your couch. And it's really important for the beginner to start out with a simple object like this before you try to make things like, say, the Sequest or a space station. But let's move on to pre-planning. The most important part of any modeling project should be pre-planning. And all pre-planning is which tools and techniques you're going to use when modeling the object. I always start my projects with a simple sketch of the object in question. It doesn't have to be real fancy, just something that I can jot down notes and dimensions about the object. For this video, I've made a blueprint for clarity, but this was derived from a simple sketch like this. Just remember, success starts with a well-defined framework. Finally, we come to measurement. If all you have is a ruler and a compass, that's all you need for measurement. Let me show you what I'm talking about. This is a compass. This is our Lego block. Simply take the compass, place it on the Lego block. We're trying to get the overall length of the object here. Take your ruler or scale, place that onto the scale, and read the dimension. Pretty simple. There's another object called a caliper that really helps. Instead of going back and forth, we just use the caliper. Simply place that on your object, and then look at the caliper and take a reading. Sometimes you'll find with a really small object, it's hard to get in there and take a dimension. Well, that's where a micrometer comes in. This is what's called a flat mic. It takes a flat dimension. If you had something round, like a piston ring, where you have a radius here and here, you want to find out what that width is. This has a rounded shaft. Simply put those two together, tighten that down, then read off of here what the dimension is. I find that when I'm modeling, I only need about two tools. That's the scale and the caliper. And while we're speaking about calipers, if you can afford it, you need to get one of these puppies right here. It's a solar-powered digital caliper. At this point, you may ask yourself, why is he covering all the measuring tools? It's important to remember, like with our Lego block, it's going to be able to snap onto another block. Or for instance, if it was an engine part, it's got to move up and down into a shaft that's accurate. Approximation gets you into a lot of trouble later on as you're doing your animation. Just remember, garbage in, garbage out. Now let's get started. Now let's begin by making a few adjustments to the modeler screen. To begin with, we need to make a couple of adjustments to the modeler setup. When you load Modeler, you should be in the Objects directory or Objects menu. Go down to the bottom here and you see where it says Options. Just hit O, that brings up our Options menu. We want to make sure we're set to one side and quadrangles for our polygon. Everything else is okay, so just hit Enter for OK. Now we need to go to the Display menu, which is up at the top here, so just hit D. And we want to make sure that instead of where it says Unit System, we want to make that say Metric, and then hit OK. Now we're ready to begin. Let's make the block. Go to Objects menu, select Box, then N for numeric, and enter the following. Negative 1.6 for X, 0 for Y, negative 0.8 for Z, and these are all low, by the way. And then we go to the high, which is 1.6 for X, 1 for Y, and 0.8 for Z. Segments is okay, and units needs to be centimeters. That's okay. So we just hit Enter. Now the box hasn't been made yet. Make sure you hit enter again to make the object. So there it is, and we still can't see it. So what do we need to do is we need to A for auto fit, and there's our block. Now, toggle to polygon mode by hitting the space bar. Just hit that twice, and there you can see here at the bottom of the screen we're in polygon mode. Now the next thing we want to do is we want to put that hole in the bottom of the block. Now some people say, well, you know, I'll just go in there and do a Boolean operation. Well, that's really not necessary. It's a lot of time involved. So what we want to do is simply lasso, holding down the right mouse button, lasso around the bottom of the block, and we'll see a normal come up because we've selected the bottom polygon. Then we want to hit the bevel tool, which is B, okay? And we want to set this to 1 for the inset. Before you enter shift, make your units millimeters, set 0 for your shift. And if you look up here in the top view, see how that was brought in 1 millimeter in both directions? Well, on our drawing, it says that was brought in 1 millimeter, just like that, and then we're going to extrude that up through the block. So the way we do that again is we go back to the bevel tool, and it still has our original settings, but this time we want to enter 0 for our inset, and we want to shift that up -9 millimeters. We hit -9, and voila, there you got a block with a hole in it. And if you want to see that, we'll simply go and hit D again for display, hit moving for preview, and solid, OK. And you come up here, our little 3D view, and voila, there it is again. Now there's one more little trick we want to do. Let me turn that off real fast just to save some RAM. If you select the bottom again, lasso right, see how it says down here in the polygon selection box that there's 4 polygons? We really don't want 4 polygons there. So if we go to the polygons menu, you come to revise, we'll see where it says merge. Hit merge, now this is -2. Deselect over here in a blank area. Anytime you want to deselect, hit a blank area of the screen. If we re-rope that, as I like to call it, we got 1 polygon. That's what we want. We don't need any extra polygons floating around here. Okay, so there's our block. One more thing we want to do. Everything about the block is flat as far as our surfacing. Before we continue, we want to name the surfaces of our block. The way we do that is simply hit the Q key to bring up the surfaces directory, hit Shift, Delete to clear that out, and type in block dash flat. And what we've just done is we've named all the surfaces of the block to block flat. If we look at our drawing, we see that in order to make the pegs are centered in 2 rows, 4 millimeters from the corner in each direction. So let me show you a little trick that I do a lot of times if I have a blueprint, is if I know for sure that I have a measurement, which we do, let's use a space bar to get back to the points selection mode. Let's pick this leftmost corner up here, and we look down here and we see 2. Come down to the face view, turn this one off, and we know now that we need to copy that 4 millimeters in each direction. Well, what we're going to do is we're going to clone that point. Go to the multiply menu and select clone. We need 1 for number of clones, and for X we want to set 4, Y we set 0, for Z we want to set -4. Now if you pay close attention, you'll notice that units down here says meters. We want that to be millimeters, so we click on the negative sign twice and just hit OK. Now if you notice, our little point popped out here. Now that's the center of that peg, okay? Now what you want to do at this point is select the peg, make sure there's only 1 selected down here, hit I for information, and it's going to tell us what the information is for that vertex. It's going to tell us where that is in our 3-dimensional workspace here. And it says X equals -1.2, Y is 1, and Z is 0.4 centimeters. So you want to jot that down. Now the next thing we want to do, let's just copy that into another layer that we're going to work from. So let's hit X for cut, 2 for layer 2, and V for paste. Okay? Now hit Alt 1 to put layer 1 in the background. Now we're ready to begin the pegs. So go back to Objects, select Disk, then Numeric. Now, to get a nice smooth look to our pegs, I'm going to enter 32 for sides. We've got 1 segment. Our axis is going to be Y. The bottom needs to be at 1. The top needs to be at 1.2. And then our center is real important. We're going to take those dimensions that we just wrote down, which is negative 1.2, 1, and 0.4. Enter those in under the center. And then our radius is going to be 0.25 for each one of these. And centimeters is okay for our units. So just enter 0.25, hit enter to round that out, and see there? They're showing us where the disk is going to be. Now, the disk isn't there until we do what? That's right. We've got to hit enter one more time to make it. Make sure you always make it when you're using these primitives. So there it is. Now that we're done with that little point, we're just going to select that. We're going to hit Z to delete that because we don't really need that anymore. That was just sort of a reference. So that's gone. One more thing we want to do before we move on is, since this is going to be sitting on the top of the block, if you hit your space bar and go to polygon selection mode, we don't need this little polygon right here. There's a polygon on the bottom there, and we're never going to see that. So we're going to select that one, hit Z, and we just cut that one out. It's gone. Now another little trick we can do, because we're going to do a couple operations really quickly here, is let's go ahead and name these surfaces. Let's lasso that top surface, like so. Make sure one's showing up down here. Hit Q again, and we've already got block flat in there. So we can just hit apply. Another neat little trick is hit shift and then the quote key, and that inverts your selection. In other words, whatever's not selected is selected, whatever is selected is deselected. Hit Q once more. This time, see where I've put my little thing on the F? Hit shift delete and type in smooth. So now those surfaces will be named block smooth. Click on a blank area and turn all that off. And now we want to clone this several times to make all the pegs. We've only got one peg made, but now we want to quickly make the rest of them. We don't need to make them one at a time. So there's two things we want to do. One, let's go to multiply menu, and there's a key called mirror. And what we're going to do is we're going to mirror the peg to the other side and then clone a row of them. So all we want to do is click up here in the top view, so that's in the center, hit numeric, make sure that's set to 0 and Z. It doesn't really matter what the units is right now. Just hit OK, hit enter to make that, and there you go. We've got our little peg on either side now. Okay, now what we want to do is we want to clone. So we're going to, once again, we're in multiply, hit clone, and it's going to ask us, well, how many clones do you need? Well, we need 3 because there's 4 on top, so we hit 3 here. And then the only thing we're going to clone in, the axis we're going to clone in, is going to be X, which is going to be 8 for 8 millimeters, because that's what our drawing told us the offset was from center to center. And everything else is going to be 0. And once again, we want to keep our units in millimeters. Bam, we're done. The reason why we still got this is the computer still thinks we're going to do a mirror function. So we just want to touch over here, turn that off, or touch polygon. So you can see how rapidly we made this from a drawing. You know, it goes back to what I said earlier. If we know the true scale of something and we've made a couple dimensions, we can just pop this thing out real fast. Now that we've made the pegs, we need to cut those back and put them back into layer 1. Now, some people may say, well, why do you work in another layer? You know, why do you have the block in layer 1 and then you make the pegs in layer 2 and you've got all this stuff going on? It's sort of confusing and I'm really lost. Think about it. If we break this down, like we said, into geometric construction methods, we've got a block, we've got pegs, and then on the bottom we're going to have little cylinders with holes in them. So let's make each one of those in a separate layer, and then we can put it all back together and save it as one object. So that's really all we did. Is if you hit 1, we've got our little block, and everything's great there. Layer 2, we've got all the pegs, and like when we hit Alt 1 to put the first layer in the background, we're just making sure everything lines up. So that all looks good. So let's just hit X to cut the pegs. Then we hit 1 to go back to layer 1. And the pegs are still in that little hold buffer on the model, and we hit V to paste them back down. And basically, if we go back and hit D again, and we go to preview and hit moving, make sure it's in solid, hit OK, now we're going to get a little bit different preview because now our pegs are there. And there we go. Got the hole in the bottom, pegs on the top. There we go. Okay, hit 2 again, Alt 1, and now what we need to do real quick is we need to make the bottom pegs or tubular pegs, whatever you want to call them. So the way we do that is we go back to our drawing again, and we can just assume, and I'm telling you, so believe me, that the peg is in the center of the block, okay? So basically we can use 0 as our reference, but what we need to know is how tall is it? Well, earlier we made a hole 9 millimeters deep in the block. Well, if we look at our drawing, 8.5 millimeters is how deep or how long the tube is. So it's a half a millimeter less than the depth of that hole. So we're going to get to that in a second when we talk about the length of or the height of the tube. To make the tubular pegs, let's go back to Objects menu, hit Disk, and Numeric. Excuse me. Objects, Disk, and Numeric. And we want to keep 32 because it just, you got to remember that some people say, well, we get a high polygon count or high point count. When you're trying to accurately model something, depending on how close or how far away you're going to be to that object, really sets the standard for the number of segments you're going to use. I'm just using 32 so it'll look fairly nice. So let's keep 32. Segments, we'll keep that at 1. The bottom is going to be at 9. Our top is going to be at 0.5. And then our center is 0, like we said, 0, 0, because we said we pretty much can say this is in the center there. And then our radii is going to be 3. Now I'm going to change this units to millimeters before I enter that last one, and I'm going to enter 3 here. Once again, I've got to hit enter one more time to make that appear. Okay. Let me turn the display off. Okay. So there's our tubular disc to start with. Once again, let's go up here and lasso that doggy right there and get rid of it. We don't even need it. Hit Z. Okay. Now go down here and select the bottom. We're going to do the exact same thing that we did before, but the neat thing about this one is we're going to combine what we did with the block and what we did with the pegs in this one little object. So already you're combining 2 things you learned. Go figure. So anyway, let's go to bevel once again, but this time let's make inset 1. It's the same thing we did before, and 0. And see there, we've got the inset right. Okay, now we know that it's negative. In this case, we're going to go negative 8.5 millimeters back up to the bottom. So we hit bevel again, 0, negative 8.5, well, not 80, 8.5. Okay, it's at the top. Now you can go ahead and delete that little guy now. We're done with him. He's done his work. He's out of there. See ya, wouldn't want to be ya. Okay, now let's do that little trick we learned again. If you circle down here, what's it say over here? 32. Well, it's flat. It's a flat surface. I don't think we need 32 polygons to make up a flat surface. So once again, we're going to go up here to Polygon, Revise, Merge. We get a negative 30 here. Just deselecting a blank area. If you click that again, you'll see that, hey, it's 1. Pretty neat trick, huh? I thought so. Okay, so the only thing we're really left to do now is to name the surfaces again, which we'll do right now. We'll hit Q, and we want to get back where we were. We're going to just scroll up to block flat, hit apply. And remember that little trick? We're going to hit shift and the quote key again. Everything is inverted. Q again. Block flat, apply. That's done. Now the only thing left to do now is we need to clone that on either side of itself. So it's pretty easy to do the first clone. And all we do is go back up to multiply, hit clone, change that to a 1. Want to set 8 in X, which is already set, and make sure it's set to millimeters still. Hit OK. Now that we've cloned that one, we simply need to clone the next one, negative 8 millimeters. Well, there's a little trick that you're going to, not really a trick, but a problem you're going to run into if you're not careful. If you go in here and simply hit clone, negative 8, and hit OK, everything looks great. But if I was to come in here and touch the center one, then hit the bracket key to select them all, everything that's connected there, I get 130 polygons. Well, that's double what we had earlier. Well, the reason why is when I cloned this, negative 8, I cloned not only this, but I also cloned this guy. So what we need to do is say undo, and now you see this is in half now. And it's good that this is selected because that's what I want. I want to have the little center guy here selected, so I'm only going to clone him to the left there. So go back to clone, -8's okay, hit OK, and now we've cloned just this guy to the left. So that's really important to remember. Now that we've already named the tubular peg, we don't have to worry about doing that. So all it's left to do now is simply cutting back into layer 1 by hitting X, go to 1, hit V to pasting back in, and we're done. Okay, we've copied all of our components into layer 1, like I said earlier, so we have a finished Lego block. And if we hit D, go up here if we want to take a look at it. Pretty amazing stuff here. I mean, it's the most incredible looking thing I'm sure you've ever made. And the only thing that's really left to do is simply save it. Just hit Shift-S to save as, and then we need to go select a directory. I like to put, I've got a directory on my system called Model Shop, and then what I do is from Model Shop, whatever the animation is, I'll simply give it a name, and then I'll put all my objects in there, and images and whatnot. And since this is for the video, we'll just go into the video directory here, and I'm simply going to call this Lego block, but of course we're going to type this in, Lego block, and just hit enter. And then you're done with it. Now if you want to see this, want to render out and see what a wonderful thing we've done here, just hit Shift Q, take us back into layout. Then you want to hold down Shift O for the objects area, hit P for panel, go up here and say load object. Once again, we got to find that directory. Model Shop, video, Lego block, all that's going to load up. And if you look up here, and we did a pretty good job, we've got 470 polygons, which really isn't bad for the amount of detail we're going to get. Simply go to our camera mode, and we can target the camera to that if we want to. Move the camera around and set up some lights, and go ahead and render this out. What I've done for you is I've gone ahead and made an animation to show you the differences between our simple block, and then I've added a little fancy rounds and whatnot to the pegs to give it some more professional or more accurate, realistic look to it. So if you look at the one on the left, that's the one we just created. Doesn't look too bad. The one on the right, in my opinion, has a little bit more realism to it. If you look at the tubes in the bottom, they're a little bit more softer. The pegs on top are a little softer. But either one of them works just fine. That wraps it up for this tape. I hope I helped you with some of your basic modeling skills. And don't forget, until next time, don't panic. It's only 3D. I'm your host, Kyle Thatch. Thanks for watching.
Motion clips. Moving clip art for desktop video, 3D artists, and non-linear editors. 8,000 JPEG frames, all on one CD-ROM.
Awesome!
Reports Video Toaster User Magazine.
This CD is a must-have for computer artists and animators.
20 scenes at 30 frames a second, all with a screen size of 752 by 480. Just perfect for the Video Flyer, Lightwave, Hollywood Effects, and Alpha Paint. To order, call 716-881-5215.
Introducing the TerraClipse Deck Alpha-based power station. Starting at under $4,000, the TerraClipse offers true performance and open-ended upgradability for the masses. Every system manufactured at Bechet Virtual Construction is a complete 64-bit multitasking workstation, ideal for all of your multimedia needs, with a well-trained support staff standing by. Don't be misled by competitors' claims. Call for your free copy of Alpha Computing and more information on the TerraClips today.
Hi, glad you could make it back to the third issue of Lightspeed. For those of you just coming aboard, I'm Carl Jasper Hoffman. With this issue, we'll explore using the alphabet as primitives for object creation. Also, I read all the posts to Lightspeed and would like to say thank you for the comments, suggestions, and critiques, both good and bad. Well, this tutorial is just a teaser to get you started, so let's dig in. For this part, we'll need the Onova medium font or one similar to begin construction of the A-ship. Bring up the font requester by clicking on the text button. Select Onova medium and type the letter A. Press the return key. Now hit the A key on the keyboard to enlarge the text in the face view. Expand the face view to the fullest, then select the multiply menu. Select mirror and place the center line on the x-axis and press the return or enter key. Press the A key again to enlarge our view. Now, before we continue, it's a good idea to check our size and model the rest to scale. Select Display in Options, then Metric. That scale and size can also be of your choosing. For the A-ship, though, we'll work in meters. Select the Modify menu, then the Size button and Numeric. Make sure meters are selected and use a scale factor of about 100. Press Return. Press the A key to fit to view again. Before we use Mirror, press the letter M on the keyboard to bring up the Merge Points requester. Press Return. In the Multiply menu, we go back to Mirror and this time start at 0 and bring the center line to about -60. Now, hold the left mouse button and move until the center line is vertical. Press Return. The letter A to fit to view and your screen should look close to this one. Press the F1 key to center the A-ship. Press A to fit the view. Using the left mouse button, drag the view down so the top view fills the screen. Now select Extrude and then Numeric. Select the Z-axis and enter 760 for the extrusion amount. Press Return. Press A for Fit to View. Deselect Extrude now. Press F1 to center the object. We're about halfway done, so take a break and save your work in progress. Drag the screen back to all three views. Select a new layer and put the first layer in the background. In the Objects menu, select the Disk button. Earlier, we used 60 meters as the mirror axis, so we know the distance between the objects is about 120 meters. Using that figure gives us a starting point to connect them together. Enter -65 and 65 for the bottom and top. Now enter 10 for the X, Y, and Z radius. Press Return. Back to the Multiply menu and select the Clone button. Enter 2 for the number of clones, and in the Z offset, enter 120 meters. Press Return. Now go back and enter a -120 in the Z offset to complete the tube connectors. Hey, almost looks like a ladder in the top view. What I like to call the ladder of modeling. Bring up the Surface requester by pressing Q and name the object's Tube Connects. Go to Layer 1 and name the object's Ship Body. With the tubes in the foreground layer and the ship body in the background, select the Tools menu and then Boolean. Now select Union to marry the two objects together and press M to bring up Merge Points and press Return. Save this object. Select a new layer and put this object in the background. Using Box from the Objects menu, press N. Now enter 140, -5, -3, 140, 5, 3, and press Return. This is going to be our stencil for the window lights. In the Multiply menu, select Array and enter the following data: for the dimensions x 1, y is 4, z is 19. Now select manual offset and enter x 1, y 30, z 40. Make sure meters is the currently selected size and press return. Press F1 to center, then in Modify, select Move and enter 140 for X and press Q and name this surface Lights On. Press the Polygon button and in the Face View, select the second and last row by holding the Shift button while using the mouse. Press A to fit to view. Enlarge the left view, select Move and enter 20 for Z. Deselect the polygons now by moving the mouse to the left and pressing the left button. Select the windows that overlap or are no longer intersecting your surface and delete them. Now randomly select polys over the surface and name them Lights Off. Cut and paste to an open layer. Put the Lights Off layer in the background. Select the inside polygons and name them Inner Ship. Press W and select Ship Body with the plus button. In the Tools menu, select Drill and Stencil. Pull down Lights Off and do the same for the Lights On. Deselect all polygons and save this object as A-Ship. Hey, you're done. All you need now is a little surfacing, some coffee, and a deck alpha. I use this method of modeling whenever I get wave block. It's kind of like writer's block, but much more severe. Well, in the upcoming issues, I'll be doing a review on Motion Master from Metro Graphics. I hope to see you then.
Hi, this is Bob Cohen, and we're going to have a look at World Construction Set, the much talked about terrain generator for the Amiga by Questar Productions. Let's get started. For those of us in the computer graphics field, the ability to create photorealistic images is indispensable. And with the past popularity of programs such as VistaPro, it comes as no surprise that the next generation of terrain generators would once again be spawned from the Amiga platform. The World Construction Set, put out by Questar Productions, is a welcome addition to what I consider to be the elite class in professional graphics tools for the Amiga. Questar does have its sights set on releasing PC versions of its software, but promises continued development for the Amiga. In fact, while we are doing this review on version 1.25, Questar is close to releasing version 2, which will offer many new tools to its already powerful arsenal, including the generation of animatable clouds. And as you will shortly see, Questar does not believe in releasing weak features. Each and every feature, of which there are many, offers the user total configurability, right down to the last detail, and their cloud generator promises to follow suit. World Construction Set is actually a very elegant 3D GIS, or Geographic Information System, which offers features to those in the field of geography, and is thus scientifically oriented. What this means to the artistic user is that every little detail in your creation can be tweaked and calibrated. On the downside, and this is unavoidable with a program of this caliber, is that you will be faced with a steep learning curve. While this is not a plug-and-play type of program, the 660-page manual that accompanies the program is extremely well written. In fact, with poor documentation of software being one of my pet peeves, I would say that this manual should be seriously scrutinized by other software developers as a model for their own documentation. With tons of tutorials, explanations, tips, screen grabs, and references, you should be on your way in just a few days, but expect to be learning this program for quite a while before you get the most out of it. In fact, as a graphics professional, you will probably never use some of the more scientific features that the program has to offer. As such, combined with the fact that this review could not possibly cover all of the features offered by this software, we will only take a look at the more basic features which you would need to use for simple terrain generation. So let's get started. World Construction Set uses Magic User Interface to create a non-modal working environment. What this means is that you can have any combination of the many windows open at the same time, and that much of what you do in one window is interactively reflected in all of the others. You'll see how this works shortly. World Construction Set requires Workbench 2.04 or higher, a suggested 12 megs of free hard drive space, and, as with any graphics program, a fair amount of RAM and an accelerator are suggested. While the program can render out in segments, thus allowing it to render with smaller RAM configurations, the ability to render full frames at a time will help speed up the process. The program works just fine with 1 meg of chip RAM. Although the manual offers directions on floppy-only installations, I don't see this as being very practical due to the sheer scope of the program and the size of the data it creates. The program creates additional data files as it requires them, so the data you start out with grows by leaps and bounds as you do things with it. The installation process is straightforward and painless with the included installer script. You are able to get right into the software after rebooting without the need to play around with Magic User Interface. But if you want to custom configure anything, it is there for your tinkering pleasure. Although you will be encouraged to register MUI for the full configuration capacities, World Construction Set works fine with the included version. The main screen offers access to the 5 modules which comprise the program. The database module is where you designate what DEMs and other objects are to be loaded by the project, which ones are active, and other characteristics of those objects like line style, color, and weight. The database files do not contain the actual DEM and vector objects. They are just database links to the actual files themselves, much like scene files are to Lightwave. Each project, which includes its own database file, also contains what is called a directory list. This is simply a listing of each object in the database and where it may be found on your system drives. This allows for two things. First, if you move files for any reason, you can tell World Construction Set so that you don't have to rebuild your database file. Secondly, it allows World Construction Set to load in only the objects that it is currently rendering, rather than loading in all the objects at once. This lets you render huge landscapes without having to have the huge RAM overhead it would take to load them all at once. You can render any number of DEM files up to and including the entire Earth with just 6 megabytes of RAM. Vector objects are used by World Construction Set to render boundaries, roads, rivers, lakes, and other details. The Data Ops, or Data Operations module, is used to translate DEM data to and from the World Construction Set format. The level of flexibility and the number of user-definable options in this module is extensive and beyond the scope of this review. The Map View module is used to view an aerial perspective of your landscape in a variety of styles, while offering multiple editing tools which are accessible in real time via your mouse or drawing tablet. Like many of World Construction Set's functions, the Map View, when set for interactive feedback, will reflect the changes made to positional data in real time. From this window, one can access the database without having to first access the icon for this module from the main screen. The Parameters module allows you to take your raw landscapes and bring them to life with color, shading, texture, and movement. You can animate a wide variety of parameters, including not only camera movement, but the position of the sun, the height of the mountains, the color of the haze and ecosystem variables, which allow you to show, for example, the changing seasons or even the growth process of landscape vegetation. The creation of your ecosystems are done from this module, as well as any importing or exporting of camera motion paths to and from Lightwave, so that you can match camera movements while using World Construction Set animations as background sequences for Lightwave foreground animations. From this module, you can open the Camera View window, which can offer real-time feedback on your camera perspective as you edit the parameters for camera from the appropriate windows. You can also open timeline windows, which are very similar in function to Lightwave's motion control editor. The user can set up keyframes for various parameters from this window, the Map View window, or the Camera View window, allowing for the most flexibility I've ever seen in this type of program. An ecosystem is a set of values used to design the appearance of the landscape and includes settings for rock, undergrowth, water, snow, vegetation, and trees. The implementation of trees in World Construction Set is a 2D process, which offers the user the most amount of detail with the least amount of RAM overhead, and they look very impressive. But with most World Construction Set parameter settings, a good deal of experimentation is required to find the best look. When creating an ecosystem, you have access to many options. For example, you can designate not only how high the elevation line is for a particular ecosystem, but from what direction it is skewed, the minimum and maximum slope allowable for this ecosystem to take hold, relative elevation effect to determine if the land area is convex or concave, and even wind azimuth, which is used to animate the waves in water in the correct direction. And like many of World Construction Set parameters, these can be animated over time. Finally, there is the Render Settings Editor module. From here, you can set the rendering options such as screen size, animation frames, field rendering, segmented rendering, which is user-definable, the save paths, Z-buffer options, motion path options such as look ahead, automatic banking, and velocity distribution, ease in and ease out, color map options, surface and grid options, fractals and ecosystem rendering options, horizon and cloud shadow options, processing options including background, blur, and Z-buffer rendering options. World Construction Set uses DEMs, or digital elevation maps, which come in all sorts of formats. They are essentially survey data which is used for multiple applications, including the creation of topographical maps. World Construction Set has the ability to load and save a large variety of DEM formats, including binary arrays, ASCII arrays, Vista DEMs, and IFF-ILBM images. Even more formats will be added to the 2.0 release. World Construction Set even loads and saves Z-buffer data sets, which essentially tells the program which objects are in front of others, so that proper depth can be assigned to each part of the rendering. And when Lightwave incorporates user-accessible Z-buffer files, the software will be able to work hand in hand with Lightwave on common projects. Now that we've had a bit of an overview of this program, let's jump in and see how easy it is to create a scene. We're going to use the Grand Canyon database with the default ecosystem and create a motion path for the camera to follow. There are several ways to create motion paths for the camera and the focus point. The focus point in World Construction Set is equal to the camera target in Lightwave. We could go about this by entering all positions numerically from the motion control area or the camera's timeline. We could also position the camera manually from either the map or camera view windows and create keys from these. But for our purposes, we are going to use a third and more intuitive technique. We're going to start by creating a vector object from the map view window's menu options. Find and select the menu option Add Points New. To the question Digitize Active Object or Create a New One, we will answer New. We will name this vector object Camera Path, since this is how we intend to use it. By viewing the terrain contours in the map view, we can visualize where we wish to fly our camera. I am placing about 10 points to describe my motion path as simply as I can. We will complete our vector object by first hitting Q and then return on our keyboard. I'll answer yes to conforming the data to the terrain. This will give an altitude value equal to that of the terrain at each digitized point. If I wanted to, I could smooth out the motion path by interpolating the vector to include more points and vertices, and thus take greater advantage of higher resolution motion splines, but for our purposes, 10 vertices are just fine. Now that we have a vector, we must tell the program to use it as the camera's motion path. I'll do this by choosing Path, Vector, Camera from the Maps View Motion menu option. Now the program wants to know what frame interval per vector segment to use. Since I have about 10 vectors and I want an animation about 300 frames, I'm going to choose about 30 frames per interval. Now, if I left things the way they are, we would have the camera looking in the direction of a fixed focus point. And since I have not bothered to set any keyframes for it, or even bothered to set its position, we obviously don't want the camera to use it. We can use the Look Ahead option to keep the direction of the camera pointing X number of frames ahead of the current position. The Look Ahead option is found in the Render module on the Motion Paths and Vectors page. From here, I'm going to set Look Ahead on and to 10 frames, and also set a very small banking value of 2, which will create the feeling of the camera leaning into turns as its direction is changed. As you adjust your settings in each of these windows, we must be careful to choose the Keep Settings button before we exit the specific module in order not to lose our options. Now the only thing left to do is set the altitude of the camera to an appropriate value for each keyframe. As you will remember, we told the program to conform to the terrain's altitude when we converted the vector to a motion path. If I left this be, I would essentially be dragging the camera along the ground. We deal with this from the timeline window. Enter the motions editor and be sure any of the camera's parameters are chosen. I like to keep the altitude selected, as this is what I use most from this window. But choosing any camera parameter will allow access to all of them from within the timeline window. Now let's open the timeline window and adjust each keyframe accordingly. Each of these triangles represents a keyframe. The red graph line represents the actual motion parameter, while some timelines, such as the one for camera altitude, will also include an auxiliary graph in green, which represents the altitude of the terrain at that current position. When a keyframe is chosen as the current one, it turns yellow, indicating that it can now be dragged to a new position or value. So now I'll place each keyframe value a distance from the ground. Alright, now that all the keys are positioned at some distance above the terrain, we can exit the timeline editor by hitting Keep. Remember, if you forget to activate the Keep function, you will have to come back and repeat this process. From the camera view window, we are going to take an initial gander at our keyframe positions in wireframe to see if we have an acceptable motion path. By moving from key to key from the camera view's command window and clicking Terrain as our drawing option, we can get an idea of how our motion path is going to look. If we find a keyframe that is not quite what we are after, we can alter it in real time from the camera view window, just like we can from Lightwave's layout window. Since I am only interested in altering the camera's altitude, I must be sure that the camera is chosen as the current and active object. By using the right mouse button, you can interactively edit the camera's altitude. When you are satisfied with the new position, click on the Make Key from the camera view command window, or use the Enter key on your numeric keyboard. Now let's render out a terrain preview, which is wireframe, with the camera view's anim function. This actually does not render out an animation, but a series of 16 color IFFs, which you can then assemble with dpaint or art department. I will set the resolution to the standard of 640 by 400. Okay, now I have 300 frames, which I converted to 4 colors, since that is all we require. This looks perfectly acceptable, so now we're ready to render out this project to the par. This animation was rendered out on an Amiga 2000 with an 030-33 accelerator card. Rendering times averaged about 30 minutes per frame. Also, the ecosystem used for the colors and textures of this landscape were simply the default values with a bit of tweaking in the fractal depth department for cleaner and smoother polygon shading. Also, keep in mind that we chose not to interpolate the original vector from which we created the camera's motion path, so the resulting motion is not as smooth as it could have been. Now that we've taken a look at what a first-time animator could realistically do with this program, let's take a look at some experienced users at work. The World Construction Set, priced at a retail of just $250, is an excellent buy for the Amiga artist. Whether you wish to generate stills or full 24-bit full-motion animation, this program can handle projects of any difficulty level. And while this version of the software is just the beginning, its power, flexibility, and configurability is unmatched. I would like to see some simpler interface options for the graphic artist who is not interested in setting up small details manually. Perhaps 2 levels of accessing the software might be in order, one for the scientific user and one for the user who just wishes to crank out some images. This in no way suggests that the program is difficult to use. The manual is concise and the program delivers everything that it promises to. And because it is so much fun to play with, the hours you will spend learning the options go by relatively quickly. The World Construction Set is only slightly more complicated to use than a program such as Lightwave, due mostly to its vast array of features. I'd like to thank Gary and Chris over at Questar for allowing me the opportunity to review the World Construction Set. I look forward to seeing their future upgrades, and I'm sure their software is going to be a big hit both in the computer graphics world as well as the scientific community. At a suggested retail price of just $250, no Amiga graphics workstation should be without it. This is Bob Cohen. Until next time.
Make sure you order a yearly subscription to Lightspeed, the video magazine for the lightwave enthusiast. Save up to 33% off the cover price. When you take shipping into account, the savings are even greater. Locate your demographics on the screen for pricing information. Don't miss any issues. Order your yearly subscription to Lightspeed today. Also, make sure to order a yearly subscription to the Lightspeed disc. Each month, along with your new copy of Lightspeed, you'll get the Lightspeed Companion Disc, which will contain objects, scenes, textures, demo products, and more. Subscribe for only $36 if ordered with a Lightspeed subscription. That's only $3 per month. Order today by calling 1-800-764-8696 or 805-726-3545. Do Do you have an idea that you think would be perfect for a tutorial? Do you have the equipment to produce a tutorial for Lightspeed? If so, please call Manual Coats at 805-945-9870 to discuss getting your idea into a future issue. If you would like to advertise your products in Lightspeed, please call our advertising department at 805-945-9870, Monday through Friday, 9 a.m. to 5 p.m. Thank you for joining us at Lightspeed. We'll see you next month.